Okay, so now I'm going to be doing chemistry paper 2, 2019, and since there's no answer book, so I have to do it on this single line paper like always. Again, out of 3 big questions, this is question 1, this is question 2, and this is question 3. We need to pick 2 out of 3. So we'll start off with industrial chem. Alright. Explain why the Haber process significantly contributes to crop yield increase. Well, this is an easy one because Haber process produces ammonia, or NH3, which can be used, I need to be careful, be used to produce which can be used to produce fertilizers. So, there's that. For question 1A21, write the chemical equation for the formation of syngas from methane. Alright, I've just done this question a little earlier. Hopefully I remember, but I think it's CH3 plus, oh shoot, is it O2? I think it is O2, right? To CO and H2, I think. And I gotta make it a 3, so then now this is 2, and then this 2, and it's balanced. For A22, we have syngas can be obtained from the conversion of biomass, suggests why it is considered as an advancement of the methanol production technology. This is strange because it is more environmentally friendly. Okay, I'm not getting a mark here. Sorry. It is more environmentally friendly, I guess. Saves energy, something along the lines of that. Okay, 3. 3 trials of an experiment were performed under the same experiment conditions to study the kinetics of the following reaction. Deduce the order of reaction with respect to A and with respect to B. Okay, this again. In trials 1 and 2, when B is doubled, well, I think this is quadrupled. Oh yeah, quadrupled. Rate of formation is 4 times large. Yep. 4 times greater, that's better. So the order of reaction with respect to B is 2. Now we're going to move on over to here in trials 2 and 3. Okay, so 418. When A is halved, here, rate of formation is also halved. So the order of reaction with respect to A is 1. Okay, that's a lot of words. Finally, we're over A. B1. A chloroalkaline chemical plant uses membrane electrolytic cells to produce hydrogen, chlorine, and sodium hydroxide. Shoot. With the help of chemical equations, briefly describe how hydrogen, chlorine, and sodium hydroxide are produced in a membrane electrolytic cell. Oh my gosh. I am not familiar with this part at all, so hip hip hooray, I guess. Oh my god. I know how to do hydrogen. So hydrogen is H plus, becomes this, right? And 2 electrons here. And then for chlorine, it's similar, chloride, and then chlorine, so 2 right here, and then 2 right here. And then for sodium hydroxide, I think it's just Na plus OH minus, I guess. Hydrogen and chloride ions are preferentially discharged. I guess. When brine is electrolyzed. Gosh darn it, alright. B2. Sodium hypochlorite can be made from the products obtained in the membrane cell. Oh, I knew this, but now I don't. I think it's just sodium hydroxide and chlorine, I think. So NaOCl plus hydrogen, I guess. So I'm going to make this a 2, and then I'm going to make this a 2, and we're even, Steven. All right. Now for B3, by using NaOCl, the chemical plant can produce hydrazine, a propellant used in space vehicles. All right. By calculating the respective atom economy for reaction 1 and 2, oh my god, do I need to? Okay, fine. Okay, for reaction 1, the atom economy is, okay, so here. 2 times 2 plus 14 times 2 is hydrazine. So 32, right? 32 plus NaCl, so Na is 23, 30, this thing. Oh, we already got them underneath. Right, then I better use this one. And water. Yeah. Reaction, I'm not gonna write the whole formula thing, so you know, just gonna skip that. 29.5. For reaction 2, it is 47.1%. So reaction 2 is greener because it has a higher atom economy. For question C1, in the industry, calcium oxide is produced from the decomposition of calcium carbonate. The diagram below shows an operating furnace for producing calcium oxide, and then blah 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 blah. They want feedstock for calcium carbonate. Feedstock? Marble. A limestone. That's better. I don't know. Limestone, yeah. C2. Explain why the injection of carbon in air can result in a higher average temperature in zone B than in zone A. An exothermic reaction happens. Happens as carbon dioxide or carbon monoxide is formed. I don't know. Maybe I've lost 1 mark again. For question for 3, the operation pressure is set at about 1 atmospheric pressure. Give 2 reasons why a higher operation pressure is not preferred. 2 reasons. I can only think of 1 reason, and that is high maintenance cost is required. I can only think 1, sorry. High operation pressure. I feel like it has something to do with incomplete combustion, or at least something to do with carbon dioxide, but I don't know what it is. But, you know, carbon dioxide is gas, so, you know, it's got to be related, right? I don't know. I have lost 1 mark. The activation energy of the above decomposition is 160 kilojoules per mole. Calculate the ratio of the rate constant at 500K to the rate constant at 200K for the decomposition of calcium carbonate. Okay. Shoot. Okay, so this is K1 and this is K2. So the ratio, okay, is log K1 over K2 equals to negative 160 over 2.3 times 8.31 times, oh, actually, I don't need to make it negative. Duh. I am dumb. I am a bit dumb. All right, 1 over this thing and 1 over that thing, I guess. So, this thing times this thing over 331, like this. And then 10 to the power of this. 1. Really? Is it just 1? 1 to 1? What? What? Is it really just 1 to 1? Really? Okay, I don't know. According to the chemical equilibrium, which suggests why the decomposition mainly occurs in zone B. Oh, so this thing is endothermic, right? So the reaction is endothermic. So higher temperature means the equilibrium position shifts to the right. More yield is obtained. All right. Boom, we have finished 1 question. This is 1 question. All right. Here we go. Question 3. We're not gonna do 2. I didn't study that. Not like I didn't study that, but our teachers didn't teach us that because it's too tough. Okay, so 3A1. Answer the following short questions. The infrared spectrum of a hydrocarbon, relative molecular mass is 40, shows an absorption peak at around 2,150. According to the table below, deduce the possible structural formula of this hydrocarbon. So first of all, peak at around 2,150, which is an What the? Wait. Oh, what the? Wait. What? We didn't. Okay, this is bullshit, bruh. This we didn't study this. This is out of syllabus. But okay, whatever, man. Means there is a carbon triple bond alkyne group. What the frick? What the? Okay. 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 So 24 4. So possible structural formula is C3H4. Since this thing is 40, I don't know. This is weird, okay? I don't know. A2. I need to stand again. The organic compounds can be extracted by suitable solvents from their aqueous solutions. Solvent would dissolve the organic compounds to be extracted without reacting with them. State 1 property these solvents should have. Nonpolar. Boom, roasted. I don't know if this is right. This is right in concept, but I don't know if this is the right answer. Okay, 3. Organic compounds. Or unreactive, I guess. Unreactive. I think this is a better property than nonpolar. Unreactive. This is definitely better. And then turns out it's nonpolar. I'm going to be so pissed. Suggest a chemical test to show how compounds A and B below can be distinguished. So this is an aldehyde. This is a ketone. Toland's reagent. Add Toland's reagent. Only A can form a silver mirror. Yes, all right. B, there we go. Yay. In order to determine, the sodium contents existing as sodium chloride in a bacon. Okay. Bacon sample, its chloride content should first be found. 2 grams of bacon sample was added to. So now we're trying to see how salty is a bacon. Was added to 2.5 centimeters cube of 1 m silver nitrate. After that, excess dilute nitric acid was added to the mixture obtained, and then the silver chloride formed was then removed by filtration. The excess silver nitrate remaining in the filtrate was then titrated with 0.1 molarity KSCN to give silver SCN in the presence of a suitable indicator until the endpoint was reached. All steps were repeated several times, and the mean volume of KSCN used to reach the endpoint was 9.42. Wow. Great. Okay. Why was excess dilute nitric acid added to the mixture? To, I guess, acidify the mixture to allow reaction, I guess. I don't know. Something along the lines of that. Draw the diagram for the setup to be used In titration. Okay, I'm not even going to use a pencil, even though I have to. But I'm not going to do it now because you will not be able to see anything if I use a pencil. Okay. Okay, and then, okay, this is really, really small. Okay. Yep, this is the conical flask with excess silver nitrate. And this is KSCN. Yeah. Barrette with KSCN. Alright. For question 3, assuming that, okay, here we go. This is the one. Assuming that all chloride comes from the NaCl, calculate the percentage by mass of sodium in the big sample. Hell yeah. Hell yeah. So we got to reverse it. So number of KSCN reacted was 0.1 times 9.42, so that's a really, really, really small amount. 9.42 over 1000, 9.42 times 10 to the power of 4 moles. Now I know that the mole ratio between KSCN and AgNO3 is probably the same because the Ag is the same and the SCN is the same. So now what we do is that we find the number of moles of AgNO3 reacted with the chloride, right? And that is 2.5 out of 1000 times 1 minus 9.42. Unless there's titration. There's no titration, right? Nope. So, okay, so we still have this. 2.5 over 1000. And then, boom, 1.558 times 10 to the power of negative 3 mole. The next step is to I'm pretty sure, okay, I'm pretty sure it's a 1-to-1, right? If it's not, I'm dead. Okay, it kind of has to be. Yeah, it appears that it is. All right. So what next is mass of sodium. Well, mass of NaCl first. And that would be 1.558 times 10 to the power of negative 3 times 50. Oh, it's not giving that to me now. It's not giving that to me. Wait a second. There is silver here. Why is silver provided if it's not used in the calculation? What the heck? I'm scared. I'm scared. Oh my god. I'm scared. What the heck? I feel like I've done something really, really, really wrong. But I don't know what it is. And that's scary, because usually I'm good at this. What the frick? Okay. 0.0911 grams. I feel like it should be way more. Bacon is salty, okay? Okay, so percentage by mass. Okay, I feel like I've done something wrong. I'm probably going to be losing at least 2 marks in this question alone. I've probably done something really, really wrong. But I'm going to still do it because I'm running out of time. So the answer is 4.56%. All right. Next. Here we go. 3CI1. Chlorine reacted with ethyl benzene under sunlight to give the mixture of different chlorinated compounds. Thin layer chromatography was used to separate a small amount of mixture. Explain why chromatography can be used to separate a mixture. Oh my god. In chromatography, I don't even know, to be honest. Different molecules, compounds have different solubilities. In the mobile phases. So they separate, I guess. I don't know. Based on the resultant TLC, suggest a method to separate a large amount of the mixture, column chromatography, right? Or liquid? One of those, okay? It has to be one of those. 2. A monochlorinated compound was isolated from the mixture. It is known that the chlorine has 2 isotopes. The mass spectrum of the compound is shown below. Oh no. By referring to the labeled peaks, deduce a possible structure of the compound. Okay, shoot. So the compound is the monochlorinated compound, right? So at MZ equals 91. 91. 91. It's 612, 612, right? 1, right? Or more like 652. So the ion responsible is the benzene ring and then 1 carbon. So, and then at MZ equals to 140, 140. So 140 minus 91 is 49. Okay. 49 minus 12. 30. Oh shit. 37 chlorine. Oh my god. So 1 more C, because here, look, 1 more C. And then 1 more H, because, well, 2 more H, because 140 minus 142 minus 140. So this is, oh, I know. No. Wait a second. Wait. I think I'm doing this right. Right? You know what? I'm going to skip the deduction part and straight up say the answer. Because, you know, it's whatevs, okay? Just pretend that I did deduce it with the MZ equals to 140. But I think this is it. You know, this is it. C, 6, H, 5, and then 12, 2, 12, 2, and then a 37. 142 for the win. All right. 3, 1. Pollutants, such as dioxins, can be formed in the manufacturing process of certain chlorine-containing products. Explain why there's a need to measure dioxin levels to, I guess, ensure the air quality. Not ensure the air quality. Measure the air quality? I don't know. To protect the people, man. suggests why dioxin levels are generally measured using modern instrumentation. Dioxin levels are really small. Cannot be accurately measured with, I guess, traditional methods. And that's it. I am gonna correct the paper and I will return. So I've just corrected it for part 1. I got a 13 out of 20. Here's the thing, I fucked this one up. I know that all of you are shouting and screaming at me when I'm making this mistake because CH4 methane, I turned it into CH3 for some reason. Very lame, not cool. Biomass is renewable. I don't know why I forgot about that as well. I also don't know why did I give myself a 4 out of 5. What the heck? Should be 3. Crap. Anyways, I didn't know this formula. I didn't know this thing exists. And I don't think it will come out again tomorrow, so it's whatevs. 6 out of 7. This one, I didn't know that this is supposed to be in joules. So, you know, all that good stuff. Also, apparently I switched it upside down. 24.8 is the right answer. And then for analytical chemistry, it's slightly better, but only slightly. I need to write immiscible, not unreactive. Prevent solid formation, apparently. So, you know, excess nitrate ions. I need to write bacon sample acidified for this one. Okay, this is really dumb because it asked us to find the percentage by mass of sodium, not NaCl. So I already fucked it up here. It's supposed to be 1.79%, but my first 2 steps are correct. In chromatography, different compounds have different solubilities in mobile phases. Yes, that is correct, but I also need to write absorptivity in stationary phases. And then this and high levels are toxic. I know that. I know this, okay? But I just didn't know that I have to write this. And this one is actually kind of correct, but I should write modern instruments are more accurate and sensitive. So overall 27 out of 40, or actually 26, which is quite tragic. So I guess I'll work harder, I guess. I don't know, man. I don't know.